So it says length, mass, temperature are all SI quantities, state other. Okay. So we just need to put quantities, not the units. So you could write length, mass, temperature, current. You could write time. You could write amount of substance, or you could have written light intensity. So any of these quantities would do, right? Two of them. No. Then it has given you this. This is the length. This is the time period. Calculate the acceleration of free fall. So first of all, we're going to write this 4 pi squared. The length is 1.50 and the time period is 2.48 whole second.
9.63.
9.63. Okay, that's cool. 9.63. And then it says determine the percentage uncertainty. Okay. We're looking at this. 4 pi is nothing. So change in G over G equals to the uncertainty in length over length plus uncertainty in T over T. Plus there is a square on T, so we're going to multiply 2. And you're going to ignore everything else because that's constants. And then because it needs percentage, you got to multiply this by 100%. So that would be 1. Oh my God. They've already given it in percentage. So nice of them. This will be 2% plus this will be 2 times 3%. So that's going to be 8%. How nice of him. Now, then it says use your answer to determine absolute uncertainty. To do that, now delta G over G equals to 8%. So we want to find 8% times 8% is 0.08 and G is 9.63 that you guys found out. So I don't know. Okay, so this is 0.7704. Now absolute uncertainty is written in only one significant figure. You guys need to remember. So it will be 0.8. And that's it. You guys have any questions, please let me know. This was pretty simple. Last time it took a lot of time. All right. Now going to the next. A dolphin is swimming underwater at constant speed. Okay. The dolphin emits a sound as it swims directly toward the stationary submerged diver. The frequency of sound heard by diver is this. The speed of water is this. Okay. Speed of sound in water. Fine. Determine the frequency emitted by the dolphin. Now it is so it is moving towards the observers. What to use? Fs times V over V minus Vs. So that would be okay. So that is the observed frequency. Okay, 9560, and we want the source minus 4.5. Okay. Let's try this. This is divided 4.5. So I'm getting F to be 9532. 9532. Because I want to write it to 3 significant figures, as all my values are 3, so I would write it as 9530. Now, because minimum, minimum significant was 3, that's why I wrote it like this. Now it says dolphin strikes the bottom. Strike the ball of bottom of a ball so that the ball rises vertically upward the surface, right? Okay. So the initial speed is given. Let's take this as positive. Then the acceleration due to gravity would be negative. Okay. Calculate the max height. So whenever something like this is given, you have to use SUVAT. You have to find this height. Initial speed is 5.6. And the final velocity is always 0. When you reach the maximum, it has to be 0. Acceleration is minus 9.81. And time is not given. So the best equation would be 2s equals to v square minus u square. Please be very careful about the signs, because then you might get math errors, you might get wrong answers. Okay, so this would be
1.6.
1.6. Okay, 1.6 meters. That's cool. Then it says the ball leaves water at time 0 and reaches the maximum height of this. Sketch a graph to show the variation of speed of the ball from t to t. Okay. The speed is going to be reduced, by speed is going to be reduced. So because the acceleration is constant, right? That is this. So it will be a straight line, but like this. So it will go from 5.6 to 0. And it will be a straight line. Because why straight line? Because this is constant throughout. It's not changing, right? You remember that? Now it says the mass of the ball is this. Use your answer in B1 to calculate a change in gravitational potential energy as it rises. So the change in gravitational potential energy would be mgh. The mass was 0.45. This was 9.81. And the height was 1.6. So again, so this is 7.1 joules. Right? Okay. Wherever you think you need help, please let me know. Now, state and explain whether the variation of magnitude of acceleration of the ball as it falls backwards towards the surface of water if resistance is not negligible. If air resistance is not negligible, right? So when it falls, like it falls back. So number 1 for 2 marks, I would write speed increases. So does air resistance, because air resistance basically depends on speed. The second point, resultant force decreases, hence acceleration also decreases, right? Because he's asking about the acceleration. So this would be this. Any questions, please let me know. All right, now going to 3. What is meant by work done? So work done, you just need to write that it is the force applied times displacement moved in the direction of force. This is very important. Okay. Now, if you see, there's a sphere is pulled along the horizontal ground, right? The sphere moves a straight line, constant speed of this at an angle this. The tension is 140. Calculate the work done by the tension move sphere at time of this. Now, it's very important. So first of all, we want to find the displacement. So displacement is velocity into time. The velocity is 4.4. And we're talking about horizontal displacement, like how much it goes here, right? Time is 30 seconds, right? Right here. So 4.4, 132. So 132 meters it travels. Okay. Now, we want to find the force that is exactly here. So I'm making 2 components. I'm gonna make one component like this, one component like this. This will be 140 cos 30 because it is next to the angle, and this is 140 sine 30. So that is the force. So work done equals to force times displacement. Oh no. Force times displacement. Force is 140 cos 30 times 130. So it is about 1.6 times 10 raised to power 4. So that should be the answer, I think. All right, now it says the weight of the sphere is 860. The vertical component of tension wire and the weight of the sphere combined. The vertical component of the tension weight. Okay. So the sphere exerts a downward pressure on the ground disk. Calculate the total area of the skis. Okay. Now, if you look at the object, this, let's suppose this is a sphere. So his weight is down, which he claims it to be 860. And upward force on the sphere is the tension one, which is 140 sine 30. He says that there is a net force. So net force here is going to be 860 minus 140 sine 30. So this is 796.4. Okay. So 796.4 meters. Now pressure is equal to force over area. We want to find area. This is this. Force is 796.4 and the pressure is 24. So what you do? Just divide it by 24. So this is about 0.33. 0.33 meters square should be the area. If you have any questions, please let me know. All right. Moving ahead with this question, it says wire attached to kite is uniform. The stress in the wire is this. Calculate the diameter. Now, stress is equal to force over area. Now the total force in the wire was actually 140. And we want to find the area first. So 140 divided by the stress is 9.6 times 10 raised to power 6. So this sort of gives me 0.1234 sorry 1.45 or 46 times 10 raised to power 5, right? So this is what, -5. And now we want to find the diameter. A circle wire has pi by 4 d squared. So I'm going to write 1.46 times 10 raised to -5, pi by 4 and d squared. So now let's do it. You multiply this by 4 divided by pi. This is the answer, and then you take under root of the answer. So the diameter is 4.3 times 10 raised to power 123 minus 3. So that should be your diameter, please. Okay. Yes. Now please do remember, if you have any questions, let me know. Then says the variation of extension of the spring. So they have given this, they say a gust of wind increases the tension from this to this. Okay, calculate the change in strain energy. So we got to find the change. Now back. First of all, I'm going to mark what is 140. So 100 is this, it means this is 110, 120, 30, 40. So this is 140. And at that point, it is this. And then what is 210? 210 would be right here, which is this. Okay. So energy, we want to find change. So always find the energies, not the, don't take change of force or anything like that. So energy 1 would be, so we are finding area under the graph, this one. So half times 140 times. By the way, this is in millimeter. So he's pretty, trying to be clever with us. And he wants answer in joules. Okay. So we want to change this. So 0.40 times 10 raised to minus 3. Let's do it. 140 times 0.40. So this is giving me 0.028 joules. And then I'm going to find energy 2. That was half times 210 times 0.60 times 10 raised to minus 3. Okay. So this is 0.063 joules, right? So we got this. Now we want to find the change. And to find the change, we always have to subtract the bigger minus the smaller in scalar quantities. So 0.035 joules should be the answer. So that's pretty all right. Yes, please let me know if you have a question. All right. Now let's see what's the next question. Okay, my favorite question is here. For a progressive wave state, what is meant by wavelength? So wavelength is basically distance between two, you can write 2 points in phase. You can also write a distance between two successive. Successive से बेहतर है write adjacent wave fronts.
Sir,
Yes.
मैंने देखा है कि distance occupied by one complete wave.
One complete wave. If you could write it like distance occupied by one complete oscillation, that would be good.
Okay, sir.
All right, the amplitude. So amplitude is the maximum displacement of a wave. Now, the beam of laser light is incident normally on diffraction grating. The moment I hear this, I know something has to be related to d sine theta equals to tan lambda. And diffraction of the light waves occurs each slit of the grating. The light waves emerges from are coherent. Okay, what is meant by diffraction? So diffraction has basically spreading of waves into geometric. It should be geometric shadows. I don't know if
sir.
it's one. Yes.
मैंने लिखा है कि spreading of waves when incident on a gap or edge.
Incident on a gap. हाँ सही है. But for 1 mark is सही. For 2 marks you should also write into geometric shadows, right?
ठीक होगा सर.
So I'm writing it full लिख देता हूँ. Spreading waves passing through a slit. Okay. Now, what is coherent? Coherent means constant phase difference. Constant phase difference between waves. Full definition is 2 waves are said to be coherent if they have constant phase difference. Now, this is given, so third order diffraction and third order there's 68 angle given, this wavelength given. It says calculate the separation d between centers of this. So we want to find d. Now d sine theta equals to n lambda. Now remember, theta is not taken from this. Theta is always taken from the 0th order, which means this was 68, which means that this has to be 68 divided by 2 is 34. 34. Right. Now we'll add the values. We want to find this. This is 34. This is the third order, and lambda is so easy. 650 nanometer. Nano is 10 raised to 9, right? All right. Now let's do this. With the calculator. Okay. So 3 into 650 times 10 raised to power minus 9. And then we're dividing it with sine of 34. So, wait. This seems like, I hate this calculator. Okay, 1, 2, 3, 4, 5, 6. So 3.8 times 10 raised to power minus 6 meters should be the answer. So the moment you see diffraction grating, only this formula, and you should know d is also 1 upon it. Now the laser light is replaced by blue laser light. State and explain the change, if any, between angle. Okay, so angle will definitely decrease. Angle decreases because, so this is 1 mark and the second mark, because wavelength of blue is shorter than red light. Or the greater the wavelength, the greater the diffraction you are going to witness. All right. I hope that's clear. Now let's go to the next. Okay, question number 5.
Sir,
Yes.
आप जरा पार्ट 3 तो एक्सप्लेन कर देंगे, मुझे समझ नहीं आई.
कौन सा? This one.
जी सर.
So just remember this, मेरे बच्चे. If this is a slit, there's a red light, right? So
जी
wavelength is around 700. Okay, 650 to 700. So red basically, if this is the zero order, red would spread more. Okay. If this was blue light passing from the same, blue is around, say, 450 to 500, right? So it is smaller one. So it's 500, 550. So it would spread less. Same for the same. Because greater the wavelengths, greater the diffraction. Is it clear?
जी सर
Yes, that's okay.
तो सर लेकिन जब वो
हाँ,
ज़्यादा डिफ्रैक्शन होगी तो ये नहीं मतलब क्या एंगल बढ़ेगा
कम होगी ना, उसने कहा मैंने रेड को ब्लू किया है,
जी
तो ये एंगल कम नहीं हो गया पहले
ओ
ज्यादा
अच्छा
था।
इसका मतलब कि बेसिकली सेम स्पेस है जो कि ज़्यादा डिफ्रैक्शन है तो ज़्यादा फ्रिंजेस बनेंगी तो उनका एंगल
जी
बीच में कम हो जाएगा
जी।
ओके और सर वैसे यूजुअली क्वेश्चन आता है वो ब्रिंज फ्रिंज ब्राइटनेस के बारे में तो उसके बारे में क्या इंक्रीज होगी ना ब्राइट फ्रिंजेस
ब्राइट फ्रिंजेस, नंबर ऑफ ऑर्डर ज्यादा बनेंगे, दैट इज
जी ठीक हो गया सर
ट्रू। ओके, नाउ ओहम, because ohm is a unit, so you have to give everything in unit. Ohm comes from resistance is voltage over current, so you don't write resistance. So ohm would be volts, 1 volt per 1 ampere. So please do remember that. So you have to define everything in terms of this. Then it says a wire has a resistance of this. The uniform cross-sectional area is also given and made of resistive. What is the length? So we should remember we have to find rho L upon A. Now resistance is 1.8. Resistivity is in SI units. Thanks to him. Length is what we got to find. Area is not in SI units, so we got to find this. Now this is in millimeter square. So how do we change this? First of all, we should remember that 1 millimeter is equivalent to 10 raised to power minus 3 meters. So we should know this. If I square this, like I take 1 millimeter square, so I have to square the whole thing here as well. So then squaring this would be 10 raised to minus 6 meters square. Now you just need to replace millimeter with 10 raised to minus 6. So I'm going to write 0.38 times 10 raised to minus 6 meters square. So like just like that, and that's done. Now, so okay. So 1.8 times 0.38 times 10 raised to power minus 6. And then you got to divide this by 9.6 divided by 10 raised to power minus 7. So it will be 0.71. Okay, up to 2 significant. Now, then say the resistor X of resistance 1 volt T is connected to resistor Y. The resistance of this and battery B. Resistor X this. So resistor X, okay, fine. The battery B is electromotive force and negligible resistance. Explain in terms of energy why potential difference across resistor X is less than EMF of the battery. Okay, so we have to give the idea, right? That why the potential difference across X is less than the EMF of the battery. It has to be less because some of the energy is dissipated in resistor Y. So you can write an equation as that. Energy of battery should be given to energy dissipated in X plus energy dissipated in Y. So it should be some equation like this, right? So of course, X would not get the total. Then calculate the potential difference of X. So what you do, there are a couple of ways to do it. You can use a potential divider. You can also use, you can find current. So I'm going to do both of them so that you guys know. So we want to find the voltage here. Okay, let's call this V out. So the formula for potential difference is V out, or let's call this Vx. So we don't get confused. So whichever voltage you find in a series combination, you write Vx, and then you say you put the resistance against it on top, and then you add all the resistances, and then you multiply with the EMF. So this is potential divider formula. If you don't remember, it is called V out equals to R1 over R1 plus R2 times EMF. So that's the formula applied. Now this is the quickest way because it just instantly gives you the answer. So let's try. 1.8 times 1.2 divided by 1.8 plus 0.6. It is 0.9. 0.90 volts. Okay. Now, if I was basically, I forgot about it, and I could also use it to find current first. So the total resistance basically would be 1.8 plus 0.60. So I'll find the total resistance first. How it just vanishes. So the total resistance will be 1.8 plus 0.60. That is 2.4 ohms. And then I'm going to use V is equal to IR. I'm going to find I. The total voltage was 1.2 and 2.4. So 1.2 divided by 2.4 is 0.5 ampere. Then what I'm going to do is I'm going to use V is equal to IR again. I'm going to use this current and the resistance of X, which is 1.8. So it will be 0.90 volts as well. So whatever you like this one or you want to do a couple of steps, that's up to you. Okay, then another battery Q of EMF this is negligible and now connected. So they are in parallel as I can see. So state whether the addition of battery causes the current to increase, decrease, or remain same. Now, I would just like to tell you that the batteries in parallel basically does not do anything different. What they do is they just have the same voltage supplied to others, but they have less current coming out. So basically, the current of this and current of this will give it the same amount of current and they will last longer. So resistor X, it would remain same and battery B would reduce.
सर आप जरा ये दोबारा एक्सप्लेन कर दें.
Yes. The current in series, in parallel, the voltage remains same. So if this is 1.2, this is 1.2, so they will also get 1.2. Do you understand?
जी sir.
The only difference it makes is that if the current that Q is giving and the current that P is giving, they add up to this to make the same current that was before. Okay?
नहीं सर, मेरा ये है कि क्या नाम है, अगर वोल्टेज बढ़ रही है पूरे सर्किट में तो करंट भी नहीं बढ़ना चाहिए क्योंकि ये दोनों डायरेक्टली प्रोपोर्शनल है.
तो पहला तुम्हारा जो है ना स्टेटमेंट वही खराब है. You just said voltage बढ़ रही है. I am saying voltage नहीं बढ़ रही. Voltage is same because they're in parallel.
अच्छा, सही है सर.
Do you understand now what I'm saying?
जी सर. और ये पार्ट 2 जो है बैटरी पी वाला,
कौन सा वाला? बैटरी पी.
जी.
बैटरी पी तो रिड्यूस हो गया ना बिकॉज पहले ए की बैटरी कितना करंट दे रही थी, अब दोनों मिला कितना करंट देंगे, so they will have to share the
सही हो गया, ठीक है सर.
now the only way
Sir?
voltage increases, yes,
If there is two supply of currents, right, it's IQ and IP, and then when they go down till resistor X, so they combine, right? So shouldn't the current value be more than what one battery was supplying?
no, the
No.
point is that let's suppose the current here was, what was the current, 0.5 ampere first, right?
Yes, sir.
Now they still are getting the same thing. Now the current here is still 0.5 because you can check the voltage these both get is 1.2. Total resistance was 2.4, so the current is still 1.5. If there are now two batteries who are supposed to supply 1.5, so this will supply 0.25, this will supply 0.25. So the overall current, first the battery was supplying 0.5 P, and now P has to supply only 0.25. Isn't it decreased?
Oh, all right. So if batteries are in parallel, they like supply half the current.
Yes, and
Okay.
only the current increase batteries in series. Then if the batteries are series, now the current would increase. Why? Because the voltage increases, as now the total voltage is going to be 2.4 volts. Do you understand?
Yes, sir. Yes, all right. Thank you.
Now the circuit is modified to produce the new circuit. Total resistance of two resistors connected in parallel. So these are this. Okay. So 1 upon R equals to 1 upon 3.6 plus 1 upon 1.8.
1.2.
Is it? Okay, when do I advance? Oh my god, that's not fair. Acha, 1.2?
Yes.
Ohms. You don't write ohms again. And the current in resistor Y. Now you need to understand something. He wants us to find the current in the main circuit, right? This hole is what, 1.2, and this is in series with this, so I'm going to add the total resistance will be 1.2 plus 0.6, and I want to find the current. So this is, I think, 1.8, you know? V is equal to IR. Voltage, total voltage is 1.2. Total current and the resistance is 1.8. Right. So what you do? 1.2 divided by 1.8. So it is 0.67 ampere. Okay. Right.
सर,
Yes.
अगर ये जो क्वेश्चन था, अगर ये होता कि 3.6 ओम का जो रेजिस्टर है उससे करंट ढूंढे, तो फिर हम कहिए कि 3.6 ओवर 1.2.
क्या कहते हैं? अगर हम 3.6 में करंट ढूंढते हैं?
जी.
नहीं. No, that would be wrong. Because here the current was 0.67, it would divide into this. अब now अगर let's suppose वो कहता है यहाँ पे करंट निकालो, right? This is your question, है ना? So first of all, we would know how much voltage this section receives, because these two things are in series, right? यहाँ पे 1.2 ohm था ना? First we'll find the voltage. So voltage received, the total current was 0.67, and the total current in this whole thing was, total resistance was 1.2. So first of all, I do this. Okay. 0.67 times 1.2. This would give me the voltage that this section receives, which is 0.8 volts. Okay. So this receives 0.8 volts. This receives 0.8 volts because they're in parallel. Now look, find the current. We'd use V is equal to IR. Now 0.8, I want to find the current in 3.6 like this. So 0.8, 3.6, 0.22.
Okay, sir. ठीक है.
Now I'm going to rub this off because I want to post the whole book right later. बाद में इन्होंने लोग को ये सर नहीं कर
Sir?
Yeah.
The way he
Yes.
calculated the current for the 3.6 resistor, if it asks the current and resistor Y, should you like calculate for both of those and Y, or could you just do Y?
I don't understand your question. Come again.
Like over here, you just did 3.6, right? So 3.6 is the resistance of one resistor only.
Yes, because we want to find the current in going through that resistor only.
Yeah, so if you want to do the same for Y, so shouldn't you take it as 0.6?
No, because in Y, you want me to find the current. In Y, the
Yeah.
current Y is in series with this. It's not parallel. So, and 1.2 is being shared with this hole and this too. So first of all, we want to find. Now, if let's suppose you wanted, you could first find the voltage here and then you could use that resistance. But we don't know what is the voltage across Y. Do you understand what I'm saying?
Yeah, all right. So basically,
So
since they
yeah.
are the free component, it works.
Yeah, the voltage that we have is 1.2, which is being applied for this whole thing is 1.2 volts. We don't have the voltage for Y. That's why we couldn't use 0.6. We found the whole resistance. Understood? And then
Okay.
found the. Now, so I can go on then?
Yes.
Okay. Now, interestingly, this is electric field. So luckily this is not there anymore, which is kind of cool. So we're moving to question number 7, which is the easiest of all. State and explain whether a neutron is a fundamental particle. No. And why? Because it is made up of quarks which are fundamental. If I were you, I'd like to write this. A proton is a stationary nucleus. A proton in a stationary nucleus decays. State 2 leptons that are produced by this decay. Now we need to understand this, very, very important. Now this is something rote learning, right? Whenever a proton decays, it will always convert to a neutron. And when this happens, it will always give you a positron, which is basically beta positive, and a normal neutrino. So now it says you need to state 2 leptons. So 2 leptons are 1 beta positive, 2 electron neutrino. This is something you got to rote learn. There's no other way. Now, then says some of the energy.
The symbol of beta positive is fine.
You can write it like this. You can write
Yeah.
it like. You can write it like I have written. Okay. Now, some of the part of the energy released by decay is given to 2 leptons. State 2 possible forms of remainder of released energy. 2 possible forms. One possible would be the kinetic energy of the new nucleus. So of course, some kinetic energy is this, takes this, so some neutron will take. The other thing that could be, and it might be a possibility of gamma. Okay, let me write gamma. Gamma symbol is this ribbon Y. Gamma radiation is released. So that is the possibility. And 5 marks. Yes.
मैंने सिर्फ लिखा है कि converted into kinetic energy, specify नहीं किया, तो क्या वो ठीक है?
Kinetic energy नहीं, वो सही नहीं है. You
अच्छा,
have to.
जी सर.
बस ही चलो. Any
नहीं
else?
सर, एक और भी चीज़ है.
हाँ.
कि मैंने इसके बाद लिखा है कि used to produce the neutron.
used to produce the neutron.
यानी
What
जो
is
एनर्जी है, क्योंकि
नहीं
क्या
नहीं
नाम,
that is not true. Decay, जब word आता है ना decay, ये A2 में तुम पढ़ोगे, decay basically means disintegration. And decay happens naturally. It is not influenced by, you can't accelerate it, you can't give it energy. वो खुद होता है.
नहीं मेरा मतलब है कि लाइक वो जो एनर्जी है ना, वो जो रिमेंडर रिलीज एनर्जी है वो न्यूट्रॉन में चली जाती है जो बन रहा है.
हाँ ये लिख सकते हो. Remainder energy can go to neutron in form of kinetic energy. And then तुम लिख सकते हो gamma is released. ठीक है.